Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, we're going to look at a concept in matrix, and this is basically under the broader discussion on the concept of a linear algebra. For today, we're going to look at the concept of minors and cofactors, and these are going to play a vital role in trying to find some of the evaluations of course procedure that we're going to come across in our various discussions on the concept of a matrix. Now, this aspect of minors and cofactors are going to be derived from specific operations that we're going to perform on a matrix. And basically, we are going to rely on a square matrix, which is going to be given in terms of an ordered n by n matrix. So in this case, I'm going to give a specific matrix, which basically is a matrix of A, which is an n by n matrix given as such. Now, from our previous discussion, we had basically mentioned that a matrix is an array of ordered numbers which are given in terms of I rows given as such, and the j columns, of course, which we are going to use in trying to define this aspect of minors and the cofactors. Now, from our last discussion, I mentioned that basically we can find a determinant of a matrix. I'm going to put a link of that specific, of course, I'm going to put a link of that specific video in our description box. So in our case here, we're going to consider an n by n matrix, whereby if we have a matrix, as I said, of A, we can define A as an n by n matrix, and then we're going to have a general element of A, which is basically an element of A given in terms of AI, J, where I, A, and AI, this I represent an I row, and J represents a column in that specific respect. Now we can define what we refer to as a minor of this specific element, which is basically going to be an element of this particular AI given in Aij, given in terms of Mij, and therefore we're going to have what we refer to as a minor of this specific AI given in terms of Mij, and we're going to have this one given in terms of an example, and that is going to be more elaborate for us. Now we can be able to, or we can determine the minor of a matrix element given in this specific order by taking our matrix over A, which is in terms of n by n, and then this can be achieved by finding an n minus 1 by an n minus 1, and therefore finding the determinant of this specific submatrix. And of course, this is going to imply a minor of this specific element of A, which we have given as Aij. Therefore, we are going to give a specific example, which is going to, of course, assist us define this specific aspect of a minor. And therefore, we're defining the concept of a cofactor. And therefore, we're going to see that cofactors basically are going to constitute specific elements which are going to be obtained from these particular minors, whereby therefore we are going to define Aij, which is a cofactor given in terms of negative 1, I plus a j, ith column plus a j row, and then we're going to multiply by the minor of I and j given as such. So basically, I've seen from this particular case the concept of minors, which are obtained by deleting the ith row and the ith column, the jth column, and therefore this is going to result in an n minus 1 by an n minus 1 matrix, which is going to give us a determinant. Now, this specific determinant, and therefore, is going to give us a minor of that specific element of A. And therefore, we have said that if we're going to obtain this specific number, which is Aij, whereby I represents a row and j a column, we're going to refer to this one as a cofactor, and this one can be obtained by a multiplication of negative 1 or an exponent of negative 1 raised to the sum of ith row and the jth column times the minor of this specific element. So therefore, I'm going to give this one in terms of an illustration, which basically is going to give us a clue on what this aspect of minors and cofactors basically represent. So, sorry for that. So we're going to have our matrix of A represented in terms of so this is going to be a column 2, 0, 1, and then we're going to have the second column as 3, negative 4, negative 1, and the last column is going to be negative 4, and then we're going to have 2 and 5 given as such. So then therefore we have said that we're going to obtain what we refer to as the minus of this specific matrix, and we have said these minus are going to be given in terms of Mij, which means they are going to consist of rows and columns, and basically these minus are going to be obtained from the determinant of n minus 1. So these are n by n matrix, which is basically a 3 by 3 matrix as we have given. So therefore these minus are going to be determinants of matrices which are going to be given in terms of n minus 1 by n minus 1, which basically means that these minus are going to be determinants of a 2 by 2 matrix given as such. So from a specific definition, then therefore we're going to say that if we're given this matrix A and required to find the minus, we are going to take these specific elements. I can just give them or list them as such. So we're going to take these specific elements of I and J. So in this case, for the I and J, they are going to represent numerical values for the first row and the first column. Therefore, for the first row and the first column of these specific elements, we have said that we can obtain a minor from this by deleting the ith row and the jth column. So in this case, our ith row for this one representing 1 as the first row, and then we're going to also delete the jth column. Our jth column, which is number 1, as of course is going to be deleted as such. So the matrix, the determinant of this remaining specific matrix, which has n minus 1, which is 2 by 2, then therefore it's going to form our first minor given in ith and ith row and jth column in that specific order. Therefore, from this specific matrix which I've given, we're going to obtain our minor, our first minor by having this negative 4, 5 as such, and the determinant from this one, of course, is going to be given in terms of this negative 4 times 5, this is negative 20, minus the product of this, which is the product of this is minus 2, so minus 20 minus 2, this is going to give us negative 18, and this negative 18 is going to be the value of our minor of 1 given as such. And then from this we're going to have our second minor of the first row, second column. Therefore we're going to delete these specific representations of the ith row and the jth column. So this means that we're going to delete the first row, so we're going to represent it in this specific case. So we're going to delete the first row of this specific representation and the second column given in that order, and then the remaining number arrangement of numbers are going to give us the determinant. Therefore we're going to have 0, 1 and 2, 5, and of course this is going to form our product for this second minor, therefore which is going to be given in terms of the determinant of this minor, which is 0 minus 2. Definitely this is going to be minus 2 given as such. And then under the first row of our minus, we're going to have the first row and the third column. Therefore we're going to delete the first row and the third column given as such. So we deleted this one and this one, and we're going to obtain, of course, the 2 by 2 matrix, which is a negative 4, 1, negative 1. And obtaining the minor for this, we are going to obtain the determinant, which is 0 minus 4, and that is going to give us the value of minus 4 in that specific order. So we have obtained an array of numbers for the first column, which is making our first set of minus, and we are going to do the subsequent ones, which are going to form our other bits of this minus and cofactors. And basically I'm going to just conclude this one for various range of minus that we need to do in order to finish this array of numbers that you have seen on the board. So by deleting the specific ith row and jth column, we're going to obtain an array of numbers which are going to represent these specific quantities for minus. And of course, if I choose this one at random, for instance, if I have this is the third row and the second column, which basically means that I was going to delete the third row and the second column, and this is going to give me a number of 2, 0, negative 4, 2. which is 2, 0, negative 4, 2. The determinant of this is 4 minus 0, therefore which is going to be equivalent to 4. So the respective numbers which I've obtained for this mith row and jth column are referred to as, of course, minus of this specific, of course, matrix which I've given in terms of A. Now we can as well obtain the what we refer to as the cofactors. And I've said that for us to obtain the cofactor, it's basically this number represented by this matrix of A, which is given in terms of negative 1, and then we have this one raised to the ith row and jth column. And this specific section basically is going to represent the summation of these various orders of matrix 1, 1. So basically, which means I'm going to add 1 plus 1 to obtain the value of 2. And the negative 1 raised to 2 is a positive number, which is 1. Now, a positive number, which is 1, times the minor of that specific, of course, element, we can just do the first one. Therefore, if we want to find a cofactor for 1, this is the minor 1, which is minor 1, 1. We're going to have the specific cofactor given in terms of 1, 1, which basically represents this arrangement of numbers. If we want to find a cofactor for this specific M21, then therefore we're going to have A21, A22, A23, A31, A32. So this specific range for numbers for ith rows and columns are going to correspond to these specific ith and jth numbers. And of course, we're going to have them, the sum of their numbers being given in this specific case, negative 1 raised to the sum of the numbers. So in this case, for 1, 1, we're going to have this one given in terms of a negative 1, and then we're going to have 1 plus 1. And then we're going to have a cofactor for the second one given in terms of 2, 1, which is going to be negative 1 raised to power 2 plus 1. And we're going to have a second one, 1, 2, basically for this one given in terms of a negative 1 raised to power negative 1 raised to power 1 plus 2. And then we're going to have this last one as 1, 3, which is basically negative 1 raised to power, this is a 1 plus 3. And these are going to give us the powers or the coefficients of these respective numbers. So A12 is equivalent to negative 1 raised to power 1 plus 2, given in that. So this is going to be 2, 2, sorry for that. Basically, this is going to be a cofactor of this specific number, so it's going to be 2 plus 2. And then we're going to have this one, 1, 2, 3, and this is going to be negative 1 raised to power 2 plus 3. And then lastly, we're going to have the cofactors of 2. So this is going to be 3, 1, row 3, column 1. Therefore, given as negative 1, and then we're going to have 3 plus 1. This is going to be 3, 2, and this is going to be negative 1 raised to power 3 plus 2, and then last 3, 3, 3, which is a negative 1 raised to power 3 plus 3. So basically, I've just given this array of numbers so that we can be able to do a follow-up. Now, in this case, if we are going to find the cofactors of these respective numbers, we're going to multiply the product we're going to obtain from this one times the minor value of the minor that we have obtained from this. For instance, if we're going to have this is first one, this is negative 1 raised to power 2, is equivalent to positive 1. Positive 1 times 18 is going to give us a product of this specific number that we refer to as a cofactor. Therefore, we're going to have the first one, in this case, represented. So let's have this specific array of numbers. So for the product between the value of this specific number for negative 1 times the ith row and the jth column, this one is going to give us negative 1 raised to power 2, negative 1 raised to power 3, negative 1 raised to power 4. So summation of these specific powers or the exponent, and this is for negative 1 raised to power 5, negative 1 raised to power 4, negative 1 raised to power 5, and negative 1 raised to power 6 in that specific order. So if we raise a negative 1 to an even power, we're going to obtain a positive value, and therefore I want us to be keen on this specific case. So implying that if we have this plus 1 is an even number, plus 2 plus 1 is an odd number. So n number that is negative 1 raised to but a specific even number is going to be a positive value, which implies the value for this specific range of a number that we're going to obtain from this one is going to be a positive 1, and this one is an odd number, therefore this is going to be negative 1. And this I'm just simplifying because of a space, and then for this one we're going to obtain a positive number, and then for this one is an odd number, therefore we're going to obtain a negative 1. Then for this one is an even number, we're going to obtain a positive 1. This is an even number, we're going to obtain a positive 1. This is an odd number, we're going to obtain a negative 1. And this is an odd number, we're going to obtain a negative 1. It's an even number, we're going to obtain a positive 1. So this basically the one that we have substituted for these specific products are the first set of this specific cofactor, and therefore we're going to multiply this cofactor by this respective minors in this specific case and come up with a particular matrix that is going to represent basically the a matrix of these cofactors. Therefore, if I have a matrix of these cofactors of A, I can represent it in terms of a matrix given as the first, this is going to be the first cofactor, or rather the first cofactor given as such times the minor giving this specific value. So I'm going to have a matrix of the cofactor given in terms of 1 times negative 18 is going to give me negative 18, and then the first row, the second column, negative 1 times negative 2, this is going to give me positive 2, and then plus 1 times negative 4 is going to give me negative 4, and then I'm going to multiply that in that specific respect and obtain 11, negative 10, I'm going to get this one 14, and then next negative 4, and then next this is going to be negative 5 and negative 8 respectively. So in this particular case, we're going to see that we can obtain minors and the cofactor of a specific range of numbers, especially for this aspect of the matrices. And these are going to assist us basically try to simplify some of the operations that we're going to come across in various ranges of the concept of matrices. Now, I hope that we have understood the concept of obtaining these minors by subtracting, of course, deleting an ith column and a jth row, and of course obtaining the determinants of these matrices, which are going to imply the minors of those specific matrices. And of course we can be able to obtain cofactors from these minors by multiplying this specific element of a negative 1 raised to ith times plus j, of course, which I've done at this lower part of the board. Now if you are asked to find the matrix of the cofactor, then therefore we're going to multiply these specific elements and therefore obtain this specific number in this order, and then we are going to arrange it in terms of a matrix which is going to be given a number or a name of the matrix of cofactors. Now whenever I'm going to mention the concept of a matrix of cofactors in my subsequent discussion, then that's why it's going to make sense that basically this array of numbers represents the value we have obtained from these two procedures of the minors and cofactors respectively. So that is it for now, guys. Bye, God bless you. Catch us in our next video.